everyone, it's Miss Lee and we are starting a new unit. We're going to be starting our probability and statistics unit, and we're looking at 11.1 fundamental counting principle and permutations and combinations. I want to remind you to pause, rewind, and rewatch any part of this video if I'm going too fast, because this is for you to go at your own pace. So first up, fundamental counting principle. This is when you have a decision to make and you want to figure out how many total combinations there are for this decision, how many possible ways to make the decision. Let's say you have decision M, it can be made M different ways, and decision N can be made N different ways. Then the two decisions can be made M times N different ways. You just multiply the total amount of decisions together. So if we were looking at example 1, the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? So we have 3 different cone sizes to choose from. Then we have 15 different flavors. You're only choosing 1, so there's still 15 possibilities. And then finally we have 1 topping to choose, and there's 8 total toppings to choose from, so we multiply that as well. 3 times 15 times 8, that gives us 360 different possible ways to create this ice cream cone. Let's try another one. Number 3, Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? Well, these are true or false, so there's only 2 different ways to answer each question. There are 12 questions and they each have the same possible ways to answer them. So 2 to the 12th power, that gives us 4,096 different ways to answer the test questions. Moving on to factorials. Factorials are represented with an exclamation point, and so you have a number in front of that exclamation point. Factorial is just the product of all natural numbers from that number n down to the number 1. So let's say we were looking at 9 factorial. That's going to be 9 times 8, 7, 6, 5, 4, 3, 2, and 1. You just multiply all of those numbers together and you end up with 362,800. 17 factorial over 11 factorial. Well, you are multiplying 17 all the way down to 1 in the numerator and 11 down to 1 in the denominator. So you actually end up canceling out all the 11 and down. So you end up multiplying 17 times 16, 15, 14, 13, and 12, and ends up with 8,910,720. 0 factorial is just 1. And why is that? That is because there's only one way to create this set. If you're creating a set of 0, there's only one way to do that. So that's why 0 factorial is 1. That's why there's a star there. Take note of that. And moving on. Permutations. So when we represent a permutation, it looks like a big P with a little number on the left, and we call that the N number, and a little number on the right, and that's R. And so permutation is just an arrangement or a lineup of objects in which order matters. And we use this formula to calculate permutation. So that's n factorial in the numerator, and in the denominator we have n minus r factorial. So there will be numbers here, and you just put those numbers into this formula. N is the total number of objects available. R is the number of objects to use for this particular arrangement. And so there is a shortcut if you are finding NPN, so the total number of objects available, you're choosing all of those objects for the arrangement, and that just ends up being n factorial. So let's look at some examples of this. If you are trying to arrange the letters in the word dinosaur, order matters, so this is a permutation. We have 8 total letters available, and we want to rearrange like this word into the same amount of letters, but just different words. So we're still using all 8. So this ends up being just 8 factorial, which is 40,320. But let's look at one where you're not choosing all of the objects available. 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? So there's 7 total students. The order matters because if somebody's chosen for first place in one way, but maybe they're chosen for third in a different geography bee, then the order would matter. So we have 7 total. We're choosing 3 for this arrangement. That means 7 factorial over 7 minus 3 factorial in the denominator, which simplifies to be 7 factorial and 4 factorial, which means I have 7 times 6, 5, 4, 3, 2, 1 in the numerator, and then 4 times 3, 2, 1 in the denominator. Remember what I was saying about 17 over 11? This is a more concrete example of that. Those numbers cancel out. So we're left with 7 times 6 times 5, which is 210 different ways. I'm flipping to the next page. There's a couple more examples for you to try on your own, so don't forget to pause and work on those problems. I'm going to keep going. Permutations with repetition. So if we are looking at number 11, how many different 9-letter arrangements are possible using the letters in the word disappear? So order matters for permutations, but in this word we have 2 letters that appear twice. So we have A in here twice, and we also have P in here twice. So to find the total amount of arrangements for this without any repeat arrangements, we have to divide by the total numbers that are divide by the letters that are appearing multiple times. So because A is appearing twice, we want to divide by 2 factorial, and same for the P, it's appearing twice, so we'll divide by 2 factorial. And so 9 factorial over 2 factorial times 2 factorial, that will get us the total number of arrangements without any repeats. So that's 90,720 possible arrangements. And moving on to combinations. So this is similar to permutations, but with combinations, the group of the objects, the order does not matter. Order doesn't matter. And so because of this, when we set up our formula for combinations, it's similar to the permutations formula. It's still n factorial on top, and in the bottom we do have this n minus r factorial, but we also have r factorial multiplied to that, and that's because we are trying to just take away all the combinations of groupings where you're going to have repeats, because order doesn't matter here. So A, B, C is going to be the same as B, C, A. So total number of objects is still n, r is still the number of objects used in the arrangement. And a shortcut for this, if you have n amount of objects and you're choosing all n in a combination, you end up with just one possible way. So some examples. Number 13. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So let me just scroll up so you can see the formula. We are choosing 8 different people with a total of 24. So order doesn't matter, because if I choose Joey first and then Mike second, it's the same as choosing Mike first and Joey second, because they're both going to end up at the party. So we have 24C8, which means I'm setting up my formula as 24 factorial on top. And in the denominator, I have 8 factorial times 24 minus 8 factorial. And when I put this in my calculator, I end up with 735,471 possible ways to choose the 8 people to attend the party. And I'll do one more. 15, there are 12 employees at the sub shop. How many ways can the manager choose 4 of the Sunday evening shift? So it doesn't matter which order they get chosen. So this is still a combination. I have 12, I'm choosing 4. Get 12 over 4 factorial. And 12 minus 4 factorial, so that's 8 factorial. And that simplifies and ends up being 495 different ways. So that's what I have for you for permutations and combinations. This next page, it asks you to determine which type you are using. So remember that permutation is an arrangement with a specific order. So the order does matter, and that's when you're going to use permutations. Combinations is a group where the order doesn't matter. So choosing who to go to a party, or choosing like the different toppings on a sandwich. But if you have a permutation, the order matters. So like choosing how many ways people can get first, second, or third place, or the order of your classes in a schedule, that would require the order to matter. So good luck with that. I'm online if you have questions.